Okay, for numbers 13 through 19, it says to find the exact value of x in each expression. And for what we have in number 13, we're looking at solving for x, whereupon we have 8 raised to the x plus 6 is equal to 4 to the x. Now, 8 is a multiple of 4, but it is not an integer power of 4. So if we were to solve without using a calculator, we can write both 8 and 4 in terms of a common base that they share. In this case, this is going to be at 2. So we have with the number 8, now 8 is both a multiple and an integer power of 2, whereupon 8 is going to be 2 to the third. And with 8 raised to the x plus 6, rewritten in terms of base 2 at this stage, you have 2 to the third quantity raised to the x plus 6 degree. And for 4 to the x, now 4 is going to be 2 raised to the second. And with 4 to the x, rewritten in terms of base 2, at the early stage, we have 2 squared raised to the x. Now, in writing, what we have in getting rid of the parentheses, we have the power property of exponents to deal with. And for what we have for 2 cubed raised to the x plus 6, this will become at the stage 2 raised to the 3 times the quantity of x plus 6. And to the right, for 2 squared raised to the x, this would be 2 raised to the 2x degree. And working with what we have on the left, we have with 2 raised to the 3 times the quantity of x plus 6. This is going to become 2 raised to the 3x plus 18 degree. And we have set equal to, once again, 2 raised to the 2x power. And we have single base 2 terms. And we can now set the powers equal to each other. So we had that 3x plus 18 is equal to 2x. Now we have 2x by itself on the right. And if I join this with 3x, and we have, upon subtracting 3x on both sides, we're going to have that 18 is equal to negative x. And just changing the signs at both ends, it's going to turn out that for the missing value x, this will end up at minus 18. So the missing value x we have in this case is negative 18. Okay, now, again, we're looking at solving for x, and whatever we have in the value or the values for x, we want the attachments x plus 7 and x plus 1 to be positive values. All right. Now, here we have on the left-hand side, we have different base 2 logarithmic terms. And what I want to do is rewrite the left-hand side in terms of a single base 2 logarithmic term. And for subtraction, again, subtraction is going to imply division. So I'm going to have the base 2 logarithm of the quantity of x plus 7 over x plus 1. And I have is equal to 2. And now we have the base 2 logarithm. The quantity of x plus 7 over x plus 1 is equal to 2. And what I can do is that I can get rid of the base 2 logarithmic appearance. Now, let me mention you have the base a logarithm of a to the r is equal to r. But also, we have a to the base a logarithm of r is also equal to r. So I can treat what I have here upon using this property. I can apply both sides of this equation to which the exponential base 2 will be raised. So I have 2 to the base 2 logarithm of the quantity. Again, you have x plus 7 over x plus 1. And we have is equal to 2 raised to the second. All right, so think of like a to the base a logarithm is going to be 2 to the base 2 logarithm. Left-hand side becomes x plus 7 over x plus 1. And 2 squared is going to be equal to 4. And if I multiply both sides by x plus 1, and for what we're going to have in effect, multiplying by x plus 1, we have the x plus 7 is equal to 4 times the quantity of x plus 1. Here we have x plus 7 is equal to 4x plus 4. And we have the appearance of like terms on opposite sides. And what I'll do here is I will take out the smaller x term. And also, I'm going to remove 4, take 4 away from both sides. So we're going to have at this stage, we have that 3 is equal to 3x, and we have that x is equal to 1, and double checking. Okay, we have 1 plus 7 is 8, which is positive. 1 plus 1 is 2, is also positive. So x equals 1 is going to check out. Okay, for what we have in number 15, we have the reciprocal of 1,000 raised to the x degree is equal to 10 raised to the 1 plus x power. Now we have, for both bases, okay, we have a common base with the number 10, which is already present on the right-hand side of the equation. Now, for what we have on the left, now we have the reciprocal of 1,000. Now, 1,000 is both a multiple and an integer power of 10, where we have 1,000 is going to be 10 to the third. But here we have the reciprocal of 10 to the third raised to the x power is equal to 10 raised to the 1 plus x degree. And now rewriting the reciprocal of 10 to the third in direct fashion, 1 over 10 cubed is going to be 10 to the negative 3. So you have 10 to the negative 3 raised to the x is equal to 10 raised to the 1 plus x degree. And now we have 10 to the negative 3x is equal to 10 to the 1 plus x. And we now have single base 10 terms given in direct fashion. And we can now set the degrees equal to each other. So we can say that negative 3x is equal to 1 plus x. And if I move the x over, and we will have in the rewrite, we have that negative 4x is equal to 1. And we have for the outcome, we're going to have a negative non-integer value for x, and this will be at minus 1/4. We have 2 times the base 4 logarithm of the quantity of x minus 2 is equal to 6. And whatever we have for x, we want to make sure that x minus 2 is going to be positive. Okay, now we have in this problem, we have even numbered coefficients on both sides. And what we can do is that we can simplify this problem. And yes, you can divide both sides of the equation by 2. Okay, so we can just get this in terms of where we're going to end up with the base 4 logarithm of the quantity of x minus 2 is equal to 3. Okay, and now we have a logarithmic base with the number 4. And what we can do, again, to get rid of the base 4 logarithm, we can treat both sides of this reduced equation as powers to which we have the exponential base 4 will be raised. Okay, so we have here, we have 4 raised to the base 4 logarithm of the quantity of x minus 2 is going to be equal to 4 raised to the third power. Here, the exponential logarithmic bases will cancel out to give us x minus 2. Here we have 4 to the third is going to be 64. And if x minus 2 is equal to 64, well, we have that x is equal to 66. Okay, for number 17, we have that 7 is equal to the base 3 logarithm of the quantity of x squared plus 162. And whatever we have for x, we want x squared plus 162 to end up as a positive result. Okay, now we have a single base 3 logarithmic term, and I can get rid of the log base 3 upon applying both sides as powers to which the exponential base 3 will be raised. So we can say that 3 to the 7th is equal to 3 to the base 3 logarithm of the quantity of x squared plus 162. Now for 3 to the 7th, okay, we're going to come out to a 4-digit number, in this case, which will be at 2187. Right-hand side, okay, again, the exponential logarithmic bases will cancel out. And so we have 2187 is equal to x squared plus 162. And upon solving for x, if we take 162 away from both sides, okay, it's going to follow that 2025 is equal to x squared. And in this case, right, so we have, and just do the commutative property of equality. So I have x squared equal to 2025. And we have with the square root property of equality. I can say that x is equal to plus or minus the square root of 2025. And now we're going to have two values of x in this case. One is going to be negative 45 and the other positive 45. For number 18, I have the natural logarithm of the quantity of x squared minus 4x plus 4 is equal to 0. And whatever I have for x, I want x squared minus 4x plus 4 to be a positive value. And now we have with natural logarithms. Now remember, natural logarithms are logarithms of base e. And I can get rid of the ln upon treating both sides of the original equation as powers to which e is going to be raised. Okay, and so we have on the left, we have x squared minus 4x plus 4. And to the right, I have e to the 0. Now, e is that 2.718 number. And a non-zero number raised to the 0 power is equal to 1. Here we have a quadratic equation. And if I set this up in standard form, we're going to have the x squared minus 4x plus 3 is equal to 0. And if I factor, we have the quantity of x minus 1 times that of x minus 3 is equal to 0. And upon applying the zero product property, if we have x minus 1 equal to 0, we have that x is equal to 1. If x minus 3 is equal to 0, well, we have that x is equal to 3. And if I plug 1 in, you have 1 minus 4 is negative. 3 plus 4 is 1. That is positive. If I do the same thing with 3, 3 squared is 9. Negative 4 times 3 is negative 12. 9 minus 12 is negative 3 plus 4 is 1, also positive. So we're going to have two solutions for x. And those solutions, again, we have at 1 and 3. Okay, for number 19, okay, we have the base 3 logarithm of x plus the base 3 logarithm of the quantity of x minus 8 is equal to 2. And once again, we have the attachments x and x minus 8. We want these to be positive. And now, for the sum of these base 3 logarithmic terms, we can make into a single expression. So the addition of logarithms, okay, is going to translate to where we have multiplication of the attachments. So we have the base 3 logarithm of x times the quantity of x minus 8 is equal to 2. And I can go ahead and distribute x over x minus 8. So I'm going to have the base 3 logarithm of the quantity of x squared minus 8x is equal to 2. And taking care of the base 3 logarithm, I can treat both sides of this rewritten equation as degrees to which the base 3, the exponential base 3, will be raised. Okay, so I have 3 to the base 3 logarithm of the quantity of x squared minus 8x is going to be equal to 3 raised to the second. For what we have on the left, we have x squared minus 8x, and to the right, 3 squared becomes 9. And if I rewrite this equation as a quadratic equation that is in standard form, I'm going to have x squared minus 8x minus 9 is equal to 0. And for what we have in the setup, so I have the quantity of x plus 1 times that of x minus 9 is equal to 0. And upon utilizing the zero product property, if x plus 1 is equal to 0, we have x equal to negative 1. If x minus 9 is equal to 0, I have that x is equal to 9. Now, upon checking, okay, now negative 1 is not greater than 0. Negative 1 minus 8 is not greater than 0 either. So negative 1 is disqualified. As for 9, 9 is greater than 0. That is true. 9 minus 8 is 1, which is greater than 0, also true. So there is only one solution that we have for x, and that is going to be only the number 9.